Okay, so let's unpack this. Today, we're going deep on something maybe a bit unexpected. An industrial tool, specifically a bandsaw.
Mm.
But as we're about to find out, with the Pedrazzoli Brown SN 420 SA semi-automatic model, even here, there's, a whole world of smart engineering. It kind of redefines things. Our mission really is to figure out what makes this machine tick. Why does it stand out? How is it redefining sawing tech? And, well, why is it seen as such a leader in design and dependability? We're working from detailed descriptions, the specs, the features, the benefits, and I'm actually pretty excited to pull back the curtain on what makes it tick, those little details behind the unmatched reliability and precision cutting.
Yeah, and what's fascinating, I think, is that it's not just about running down a spec sheet. It's really about appreciating how all these meticulous design choices, they add up. They translate into real benefits for you, the user. Things like better productivity, sure, but also making the blade last way longer and just getting consistently better cuts. We'll see how those foundational decisions ripple through its whole operation.
That's a great way to put it. So let's start right there, at the foundation. Stability and their design philosophy. The source is called Pedrazzoli, an industry leader, saying they redefine the landscape of sawing technology. That's a pretty bold statement for a bandsaw, isn't it?
Yeah.
From an engineering angle, what's really different or clever about how they start?
Well, this is where their experience, really comes through. They put a huge emphasis on a stable saw platform. And it's not just like a nice feature, it's absolutely fundamental. Because that stability, it directly impacts your productivity, how long the blade lasts, the quality of the cut, the squareness, everything. Think about it, if the base isn't rock solid, every single cut inherits that tiny bit of instability.
Right, okay. And the big part of that stability is the physical build. You mentioned the robust, heavy-duty cast iron bases. Why cast iron? What
Yeah.
makes that the go-to material here? How does it give you that flawlessly smooth sawing operation?
Ugh. Cast iron is perfect for this. It's not just heavy, although the mass helps, definitely. The key is its internal structure, its sort of cellular makeup. It's naturally brilliant at dampening vibrations. So all those little micro vibrations from the motor, the blade moving through the material, the cast iron just absorbs them, soaks them up. Less vibration means less blade chatter.
Less chatter.
Okay.
It's a smoother cut.
Exactly.
Yeah.
Smoother cut, better finish on the material, and much better accuracy, cut after cut after cut. It's a fundamental material science choice, really. It shows they're thinking about long-term precision, not just making it stiff initially. Plus, they mentioned it's manufactured and assembled with years of fabrication experience. So it's not just theory, it's a proven practical design.
Gotcha. So for you using it, that solid base means cuts are more consistent, less material gets wasted from bad edges, and the machine itself is just built to last. Makes sense. Okay, so you've got this incredibly stable platform. The next thing you need is control, right? Versatility and precision. This machine has two modes, manual or this semi-automatic cycle control of bow movement. Can you break down bow movement for us, and what does that semi-auto function actually do?
Sure. The bow is basically the saw head, the part that holds the blade and lowers down to make the cut. In semi-automatic mode, it's all about efficiency and consistency, especially for repetitive cuts. You usually kick it off with a foot pedal. Then there's a flow regulator that controls how fast the bow comes down. So you get this really nice consistent feed rate into the material. And here's the neat part. Once the cut's done, the bow returns to start position while vise remains closed.
Okay, so the material stays clamped.
Exactly. Stays clamped, bow goes up, ready for you to feed the next piece or the next cut position. It really smooths out the workflow.
Yeah, I can see how that would speed things up. And what about angled cuts? It mentions a large diameter mitre base that glides easily over tempered bearing track. Sounds smooth. How much angle can you get?
It's pretty flexible there. The whole saw head can rotate smoothly from 60 degrees left all the way to 45 degrees right. And it has fixed stops for common angles. That covers most of what you'd typically need in fabrication, basic miters, compound angles, that sort of thing.
Okay. And besides the angles, it also talks about variable blade speed adjustment and two blade speed selections. Why the different speeds? Is that just for different metals?
Pretty much, yeah. It's key for optimizing the cut and making the blade last longer, depending on what you're cutting. It's like drilling, right? You wouldn't use the same speed for wood as you would for steel. Generally, you go slower for harder metals, helps prevent overheating, saves the blade teeth. Faster speeds might work better for softer stuff or certain profiles. So having those options gives you the flexibility to really dial it in for the specific job, whether it's ferrous or non-ferrous tube, pipe and profiles. It lets you get the best cut every time.
Right, adaptability is huge. Okay, moving on to actually ensuring that precision cut and holding the material right. The sources mention vise shoulders that retract and adjust to support material effectively, consistently, to the profile being cut. That sounds like a small detail, but may be important.
Oh, it's absolutely vital. You need to hold the material perfectly square and secure, especially if you're cutting something that isn't just a flat bar, like tubing or an I-beam. These adjustable shoulders make sure it's gripped properly, right near the cut line. And then, to help you line it up perfectly before you even clamp it, there's a laser indicator for aligning cutting position.
A laser guide. Okay, that seems handy. Less guesswork.
Exactly. It projects a clear line right where the blade will cut, so you can position your material with pinpoint accuracy, reduces setup time, cuts down on measurement errors, saves material. It's a great feature.
And the blade itself needs guidance too, right, to keep it cutting straight. It mentions blade guide arms adjustable to dimension of workpiece, and these blade guides feature 2 hardened guides on eccentric bushings. What exactly are those doing? Sounds pretty technical for just holding a blade.
Huh. Yeah, it sounds complex, but it's actually a really clever bit of mechanical design. They're kind of the unsung heroes of a straight cut. Think of an eccentric bushing as a small cylinder where the hole isn't perfectly centered. By rotating it, you can make tiny, tiny adjustments to the position of the blade guides. You can push those hardened guides right up against the blade, just kissing it to make sure it tracks perfectly straight through the cut with basically 0 sideways movement or wobble.
Ah, I see. So it's for ultra-fine adjustment of the guides.
Precisely. Even a tiny bit of blade deflection can mess up the squareness of the cut, or worse, cause the blade to wear out prematurely or even break. So this system, combined with the blade tensioning hand wheel with spring for uniform tensioning, which keeps the blade pulled tight, ensures the blade stays true. That's how they can claim that unmatched quality and squareness.
Okay, that level of detail makes sense. So clearly, it's built for precision, built for handling different materials.
Yeah.
But does it last? Precision is great, but not if it needs constant fixing. How's the durability?
Yeah, that's always the question with complex machinery, isn't it? Longevity seems to be a core part of the design here, too. One really key thing is the drive system. It uses a vertically mounted saw motor, reducing overall dimensions of transmission to worm gear drive with full oil bath. Okay, breaking that down. The worm gear drive is known for being very robust, good torque, and it's self-locking, which is a plus. But the critical part is full oil bath.
Meaning the gears are just swimming in oil.
Pretty much, yeah. Constantly lubricated. This massively reduces friction and wear on the gears compared to, say, grease lubrication that might break down or get pushed aside. Less friction, less heat, much longer component life, and less maintenance.
Okay, that makes sense. And I see other notes here too, like the saw bow movement supported with conical bearings. Those are usually pretty tough bearings, right? And again, that heavy cast iron saw base for greater rigidity.
Yeah.
It all seems to point towards being built tough.
It really does. It feels like every major component choice was made with durability and minimizing long-term wear in mind. Even the maintenance seems considered, like the coolant reservoir with removable electric pump for easy cleaning. Sounds simple, but keeping coolant clean is important, and making it easy means it actually gets done.
So for you, the takeaway is you're investing in something that's designed to really go the distance, less downtime, less hassle with repairs, should save time and money over the long haul. All right, last big area. Safety and just, how easy it is to actually use. Safety is obviously huge in any workshop. What's built in here?
They seem to have layered the safety features quite well. First, there's a blade drive safety switch located in the hand grip. So you have to be actively holding the handle correctly for the blade to even run. Then there's a safety micro switch standard, but crucial, that prevents blade operation when the guard is open. No accidents while you're changing a blade or checking something. And maybe most importantly for active safety, there's an electronic safety sensor that stops band motion in case of breakage.
Oh, wow, okay. So if the blade snaps...
The machine stops instantly. Or near instantly. That's huge for preventing injury or further damage if a blade fails under tension.
Yeah, absolutely critical. That's comprehensive.
Yeah.
What about just using it day to day? Is it intuitive?
It seems designed to be pretty straightforward. The control panel with simple operator control functions suggests they haven't overcomplicated the interface. You've got your basic machine on-off switch with lockout switch, which is good practice, prevents anyone from just walking up and turning it on accidentally. And then there are practical touches, like the length stop with micrometer adjustment for setting cut lengths accurately and repeatedly. Oh, and the base is designed to accommodate forklift, makes it way easier to move around the shop if you need to rearrange things.
Right? Little things that make a difference. So for you, the operator, It's about feeling safe while using it, and hopefully it's not a steep learning curve. It just works. So wrapping this up, this deep dive really shows just how much thought can go into a tool that maybe seems simple from the outside. Every detail, from the cast iron's vibration damping to those little eccentric pushings, the safety sensors, it all adds up. It all contributes to performance, safety, making it last. And here's what I find really interesting. It's all these seemingly small things, right? Each one carefully considered, executed properly. They build on each other to create something genuinely impressive. It's not just a bandsaw. It feels more like a testament to getting the fundamentals absolutely right.
Exactly. And if we connect this to the bigger picture, it reinforces that idea, doesn't it? That real excellence in almost any field often comes down to mastering those fundamentals, perfecting the basics, understanding why things work, and executing meticulously. It's not always about flashy reinvention. Sometimes it's about perfecting the core principles. So maybe a final thought for you to consider as you process all this. How could applying that same kind of rigorous, detail-focused design thinking, that focus on fundamental stability, on the user experience, how could that change other areas, other industries, maybe even how you approach problems yourself? What other seemingly simple tools or processes in your world might actually reveal some deep design principles if you took a closer look? Worth thinking about.